You know that feeling when you're searching for something really specific online, something complex where you need like a real understanding, not just a keyword match. You're hunting for an answer that seems like it actually thought about your question.
Hmm. Definitely.
Well, today we're doing a deep dive into an advancement in information retrieval that's trying to give you exactly that. Think of it as a shortcut to deeply reasoned knowledge. Our topic is ReasonRank. It's this fascinating new development pushing search beyond simple matching to genuinely, well, reason about information. And our mission today is to explore how ReasonRank tackles those really tricky, complex queries. All our insights, by the way, come from a research paper called ReasonRank, Empowering Passage Ranking with Strong Reasoning Ability.
Right. So when you type something into a search engine, there's this crucial step, often invisible, called passage ranking. It basically refines the first wave of results, zeroing in on the most relevant snippets or passages to give you better quality answers. And large language models, LLMs, they've shown some incredible promise here, especially with something called listwise ranking.
Listwise ranking, that's different from looking at passages one by one.
Yeah, exactly. Instead of judging each passage in isolation, listwise ranking looks at a whole group of potential answers together for one query. This lets it capture much more complex patterns of relevance, sort of sees the bigger picture. But there's a challenge, and this is what ReasonRank really targets. Even these powerful LLM re-rankers often struggle when a query demands genuine reasoning.
Why is that?
Well, it often comes down to the training data. Things like the classic MSMRCO dataset, which is common web search data, mostly focus on, let's say, simpler lexical or semantic matches. Word matching, essentially. That works okay for straightforward questions, but it falls short when you need deeper, more logical understanding.
Ah, okay. So it sounds like there's this big data gap. You see real-world questions, maybe on places like Stack Exchange, that need complex reasoning, right? You need to connect evidence or find solutions using similar logic, not just keywords.
Precisely.
But the paper mentions a huge bottleneck. Getting humans to annotate enough data for that kind of complex reasoning is just incredibly expensive, basically unfeasible at scale. So how does ReasonRank get around that?
That brings us to ReasonRank's first really big innovation, what they call an automated data synthesis framework.
Yeah.
It's designed to tackle exactly that problem, the scarcity of reasoning-intensive training data. And it does it automatically, without needing massive human annotation efforts.
Automated data synthesis. Intriguing. How does it work? What kind of data does it create?
It pulls queries and passages from really diverse sources to build this synthetic data set. Think about it. Complex questions from Stack Exchange, covering fields like biology, earth science, economics, robotics, even Stack Overflow for coding, and sustainability. Places where relevant answers often involve key concepts or theories, not just keywords. Then you've got coding problems from LeetCode, where it's looking for passages sharing specific algorithms or, similar logic.
Right, like finding the method, not just the topic.
Exactly. And for math, they use problems from the math dataset. It focuses on finding passages with similar problem-solving logic, or maybe related theorems. And to cover the bases, they still include simpler web search queries from MSMRCO too. So it's a really broad mix.
Wow, that is diverse. How do they actually generate the right connections and rankings within that data?
That's where a powerful large reasoning model called DeepSeek R1 comes in. It's kind of the engine driving this data synthesis. DeepSeek R1 automatically identifies the positive passages, the truly relevant ones, and also hard negative passages.
Hard negatives, meaning ones that look relevant but actually aren't.
Yeah, the tricky ones that might share keywords but don't actually answer the question or provide the right logic. Crucially, DeepSeek R1 also generates reasoning chains.
Reasoning chains, like its thought process.
Pretty much. Detailed, step-by-step logical paths showing how it determined relevance. And it also creates gold ranking lists, the ideal, correctly ordered list of passages for each query. These chains and gold lists become the high-quality training labels for ReasonRank itself.
And I read something fascinating here. They actually give DeepSeek R1 the gold answer during this data generation phase. Doesn't that feel like cheating?
It sounds like it at first, doesn't it? But it's actually quite clever. It's not about letting it just copy the answer. Think of it more like giving a student the answer key, not to cheat on a test, but to study how the correct solution is constructed.
Ah, okay. So it helps DeepSeek R1 understand the query's nuances better.
Exactly. It helps it grasp what a good answer looks like and why it's good, which then allows it to generate much higher quality reasoning chains and ranking labels for training ReasonRank.
That makes sense. Quality control must be important too, with automated generation.
Absolutely. They use something called a self-consistency data filtering mechanism.
Hmm.
It basically filters out any lower quality training samples. It uses a ranking metric, NDCG at 10, to check how well the generated gold rankings align with true relevance. This whole rigorous process results in about 13,000 high-quality, really diverse training data points.
Okay, so they've tackled the data scarcity brilliantly. That's the foundation. But having the data is one thing. How does ReasonRank actually learn to use it? How does it develop that strong reasoning ability? What's the training secret?
Right. That leads us to ReasonRank's two-stage post-training approach. It's designed specifically to build that reasoning capability into the reranker. Stage 1 is called Cold Start Supervised Fine-Tuning, or SFT. This initial phase uses all those generated listwise labels we just talked about, the reasoning chains, the re-rank lists, everything. Its purpose is to help the backbone LLM they mention, using models like Qwen 2.57b Instruct, or even the larger Qwen 2.532b Instruct, learn the specific reasoning patterns needed for effective listwise ranking. It's like building that fundamental understanding.
Got it. So SFT lays the groundwork. What's stage 2?
Stage 2 is reinforcement learning, or RL. This is where the model refines and enhances its ranking ability even further. It helps the LLM explore potentially even better reasoning patterns beyond the initial SFT training.
And for this RL stage, they did something innovative with the reward system, didn't they?
They did. They designed what they call a multi-view ranking reward. Now, previous RL re-rankers often relied on a single metric, usually calculated turn by turn. ReasonRank's multi-view reward is different because it considers the multi-turn nature of the sliding window listwise ranking approach.
Sliding window, right, because it looks at chunks of passages.
Correct. So this reward combines 3 different metrics. First, NDCG at 10. That's a common ranking metric that prioritizes getting the best results near the top of the list. Second, recall at 10, which makes sure important relevant passages aren't missed entirely within the top 10. And third, rank biased overlap, or RBO. This one measures how similar ReasonRank's final ranking order is to the ideal gold standard ranking list generated earlier.
So combining those 3 gives a more complete picture of ranking quality.
That's the idea, a more comprehensive evaluation of the final list it produces. And they also include format rewards in this RL stage.
Format rewards.
Yeah, these just ensure the model's output follows the structure they expect. Specifically, making sure it generates distinct think sections where it outlines its reasoning and answer sections, which contain the final ranked list. It keeps the reasoning transparent.
That's an incredibly thorough training process, SFT, then RL, with this special multi-view reward. But, okay, the million-dollar question. How well does it actually perform? What did the results show?
The results are pretty striking, actually. ReasonRank significantly outperforms the existing baselines. And that includes other re-rankers that also try to incorporate reasoning, like Rank 1, Rank R1, Rank K. It does particularly well on benchmarks specifically designed to test reasoning-intensive information retrieval, like Bright and R2MED.
How much better are we talking?
Well, to give you some numbers, the larger 32B scale ReasonRank beat the previous best baseline on the Bright benchmark by about 5 points. And on R2MED, it was ahead by about 4 points. What's also quite impressive is that even the smaller 7B scale ReasonRank managed to outperform some of the 32B scale baselines from other methods.
Wow, so the 7B is punching above its weight.
Definitely suggests the training approach is very effective. And overall, ReasonRank achieved a new state-of-the-art performance score of 40.6 on the Bright leaderboard at the time of the paper.
Okay, state-of-the-art performance is great. But here's something that really jumped out at me. Speed. Despite all this complex reasoning, ReasonRank, which is a listwise re-ranker, is apparently faster, like 2 to 2.7 times faster than a pointwise re-ranker, like Rank 1. How's that possible? More thinking, but faster.
Yeah, it seems counterintuitive, doesn't it? But the reason is actually quite elegant. Pointwise re-rankers, like Rank 1, have to generate a separate reasoning chain for every single passage they evaluate.
Ah, okay, so lots of repetitive reasoning generation.
Exactly. ReasonRank, being listwise, processes multiple passages within its sliding window at the same time, and it generates only one reasoning chain for that entire batch.
I see, so way fewer reasoning chains overall.
Right. It dramatically cuts down on the total number of output tokens the model needs to generate, and that leads to that significant speed increase.
That's clever. What about traditional search tasks? Does it still work well there?
It does perform well on traditional IR benchmarks like BER2. Its ability to generalize is solid, though the performance gap between ReasonRank and the baselines is smaller on those benchmarks.
Why is that?
Primarily because those queries tend to be simpler. They just don't demand the same level of complex, multi-step reasoning that ReasonRank is specifically designed and trained for, so its unique advantages aren't quite as pronounced there.
Okay, that makes sense. To really understand why ReasonRank works so well, the paper does an ablation study, right, where they remove key components to see the impact.
Yes, those studies are always illuminating. They really help pinpoint what's driving the performance.
So what did they find? What are the crucial parts?
Well, first off, that diverse synthesized training data is absolutely essential. If they trained a model using only traditional web search data, like just MS Marco, the performance on the reasoning benchmarks dropped significantly by over 5 points.
Wow, 5 points. So that diverse data is non-negotiable for reasoning tasks.
It really underscores the need for it. Second, that two-stage training process is crucial. If they skipped the initial supervised fine-tuning stage, the SFT, performance plummeted by over 7 points.
7 points. So that foundational learning is vital.
Absolutely. And removing the second stage, the reinforcement learning, also caused a noticeable drop, over 2 points. So the RL clearly plays an important role in refining and boosting the ranking ability further.
What about the reward system? Did the multi-view reward make a difference?
It did. When they tried using just a single-turn ranking metric, like older methods, instead of ReasonRank's tailored multi-view reward, performance also went down. It confirms that the more sophisticated reward system is beneficial.
And maybe the most fundamental question, does the reasoning itself actually help?
That's a key finding. They trained a version of the model without explicit reasoning chains, just giving it the gold rankings to learn from directly. And that model showed a clear performance gap compared to the full ReasonRank model. It demonstrates that the explicit reasoning process, generating those think steps, significantly enhances the final ranking effectiveness. It's not just about getting the order right, it's about understanding why it's right.
Fascinating. So every major component seems to pull its weight. The paper also mentions some further ranking enhancements, ways to potentially push performance even higher.
Yes, they noted a couple of things. Using even better initial retrieval results, meaning the candidate passages fed into ReasonRank in the first place, can obviously help. Garbage in, garbage out, as they say. And they also found that tweaking the sliding window parameters could give a boost. For instance, using a slightly smaller window size, like 10 passages, with a stride of 5, meaning the window shifts 5 passages at a time, helped them achieve that state-of-the-art 40.6 score on Bright.
Right, optimizing the parameters for the specific task. Okay, theory and results are one thing, but could we, walk through an example? How does ReasonRank actually think about a complex query?
Sure. The paper gives some great case studies. Let's take an Earth science query. It's quite complex. The line on the ground at the Greenwich Observatory is itself on a tectonic plate that is moving. Is the prime meridian still 0 degrees, 0 minutes, 0 seconds? If not, what are the implications? Who and what decides this kind of thing?
Okay, lots of parts to that question.
Exactly. And ReasonRank's think process, its internal reasoning chain, immediately starts to focus on passages discussing the key concepts: tectonic shifts, the role of GPS references in defining modern coordinate systems, and importantly, the authoritative bodies involved, like the BIH or IRs, who manage these standards.
So it's not just matching prime meridian or Greenwich, it's connecting the concepts of movement, implications, and authority.
Precisely, it identifies which passages actually explain the dynamics and the decision-making involved.
Let's try another one, maybe biology.
Okay, here's one. Why does hair turn gray or white? And why does it happen later for some? What is happening molecularly?
Ah, the mysteries of aging.
Indeed. Here, ReasonRank's reasoning looks for passages detailing the specific biological mechanisms. Its think process seeks out terms and explanations related to melanocyte stem cells, the role of oxidative stress, maybe genetic factors, even things like telomeres. It's hunting for the molecular explanations, as the query asked.
It actively searches for the what is happening molecularly part.
Right. It prioritizes passages that offer that level of detail.
What about something like coding from LeetCode?
Good example. Query. Given an X in Arioner's matrix, return the length of the longest increasing path in matrix.
Okay, a standard algorithmic problem.
Yes. And ReasonRank's thought process here shows it repeatedly verifying and comparing passages. It's actively looking for specific algorithms or data structures that are relevant to grid traversal problems, maybe dynamic programming approaches, or memoization techniques.
So it's looking for the solution pattern for this type of problem.
Exactly. It's not just matching the word matrix or path. It's trying to identify passages that describe the logic needed to solve the longest increasing path problem in a grid setting. It ranks passages based on how well they explain or implement that relevant logic.
These examples really make it clear how different this is from simple keyword searching. It's genuinely trying to understand the underlying need. So wrapping up our deep dive then, ReasonRank really does seem to be a state-of-the-art approach for reasoning-intensive passage re-ranking. Its strength seems to boil down to those two core innovations, right? That automated data synthesis framework solving the data problem.
Which is huge.
Yeah. And that two-stage training process, SFT followed by RL, with its unique multi-view reward system to really hone the reasoning.
Yeah, I think this work really shows something important. It demonstrates how integrating these sophisticated reasoning capabilities directly into the ranking process itself, especially when you support it with high-quality synthesized data tailored for reasoning, can lead to really powerful performance gains. And surprisingly, it can even be more efficient.
Yeah, the speed aspect was unexpected.
But it really points towards a future where search systems can genuinely,
Understand what you're asking for on a deeper level.
So maybe a final thought for you listening. Imagine how systems like this, systems that can truly reason about information, could change how we discover knowledge, especially in really specific, nuanced fields. We could move far beyond just matching words, uncovering deeper connections and insights in research, technical problems, or complex inquiries that you might completely miss otherwise in today's, well, overwhelming sea of information.